All right, class. For this assignment, each problem requires 4 things. So for each one, you got 2 graphs you got to make. You got to graph the function and its parent function. After you graph them, just label both of those. And then we got to do a quick description of the transformation, what happened. So 4 things for each problem. Let's start with this one. F of x equals x minus 4. So what we'll do is we'll just think, okay, oh, I know you guys. You guys like to write y. Y equals x minus 4. When your number hanging out on the end down here, oh, that's going to move it. That's a translator. Out on the end, this guy is responsible for moving your function up or moving it down. So since it's a negative 4, you're right. Negative 4 means you're going down 4 spots. So we're going to draw a quick graph of this and its parent function. Let's see what it'll look like. Maybe I can fit this on the end. Maybe. Let's see if I got enough room down here. Can you see that? Oh, you can see it. Awesome. So right here is 0, 0. So 1. Ooh, that didn't turn out very good. Hold on just a second. Draw a little straighter. So there's me a quick graph. My function, oh, down 4, sorry. It's going to be going down 4 spots. So here was 0, 0. Here is down 4. So my new graph, linear, going this direction. That's down 4 spots. And then this is my parent function. I got to label both of these. This is the one that's my function I just graphed, y equals x minus 4. Here's my parent function, y equals x. So on each problem, you've got to graph the function, got it. You got to graph the parent function, got it. You got to label both of them, y equals x minus 4. Then you got to talk about the transformation, like did we reflect this? Is it a translation that moves horizontally left, right, or vertically up, down? This one went down 4 spots, so it's definitely a vertical translation. So you've got to decide what kind of translation is it? Is it horizontal or is it vertical? It's vertical, went down 4 spots. So we just write 4 units down. So it's a vertical translation, 4 units down. And that answers our last part about describing it. So each one of your questions is going to look like this. Graph, labels, describe the transformation. All right, let's do some of these. Okay, number 2. F of x. Let's go up. How about x plus 5? Yeah, as soon as you see it's x plus 5, for your linear, hanging out on the end down here, that's up or down. Plus 5 indicates we're going to be going up 5 spots. So we'll sketch our graph. Here's 0, 0, 1, 2, 3, 4, 5. So we've got to graph our function and the parent function. So here is... So there's our 2 linear graphs. Here's my parent function, y equals x, labeling that. Here's the function they gave to us, x plus 5. So you've got your 2 graphs, done. You've got them labeled, done. And then you got to describe this. It's definitely a vertical translation. And then you just tell how many units up, down, left, or right. Looks like we went 5 units up. And there you go. All right, let's do some absolute value and some quadratics. Let's mix it up. Three, g of x equals x minus 3 squared. Okay, as soon as you see this square jumping into the picture, you're thinking, oh, squared. know what that means. It's going to be quadratic. I've got a parabola that's going to show up. What we've got to decide is if anything's going on inside your parentheses. Now this is a crazy deal you got to be ready for. If there's a number inside the parentheses, inside here decides whether we're going left or we're going right. And the crazy thing, it's always opposite of what you would think. So inside the parentheses, if you see -3, you would think going left, but it's the opposite. You're going right 3. So inside parentheses, change it. -3, +3, you're going right. So let's graph this one. So we have a quadratic, yes. Parabola, yes. So there's my parent function, there's my normal parabola, and I'm going to move it right 3 spots. 1, 2, 3, right here. And I've got it labeled. So anything inside the parentheses, think opposite. Outside the parentheses, it stays what it means. Inside something, that's different. All right, guys, graphed it, labeled it. Let's describe this. Ooh, it's a left-right translation, so that means horizontal. So a definite horizontal translation, and let's say how many units we went. We went 3 units right. Okay, so the 4 things you've got to do: graph the function, graph the parent function, label it, and then you got to describe what's going on. Yeah, now we're feeling good. All right, 1, 2, 3, 4. Y equals x squared. Okay, no parentheses on this one. All right, so you look at this problem, there's no parentheses going on. This is just y equals x squared minus 4. So you're back to having a value out on the end. If he's out on the end, if there's no parentheses, this is back to the up-down. So this guy up here decides up or down. It holds true to what you think. So -4 means down 4. All right, let's put a graph on this. So we're doing quadratics still. Quadratics squared definitely means parabola. Let's throw a parabola on there. So there's my parent function. This function is down 4 from that. And I got it labeled. Now we just got to decide what happened here. Was it a reflection? Was it a translation? Definitely up-down means vertical. So this is a vertical translation. And then you just state how many units you went in which direction, down 4. So this would be 4 units down. So each question you do 4 things for, graph them, label them, describe them. Got it. All right, 1, 2, 3, 4 in the books. Let's do number 5. Let's do some absolute value. We haven't done that yet. Let's get those absolute value bars on there. Okay, so on absolute value, if you're inside these bars, it's the same rule for inside the parentheses. If you're inside it, you go opposite meaning. Okay, so inside there dictates we're going left or we're going right. but it's always the opposite meaning. So when you see minus 6, you think, oh, that's saying left, but we go opposite. So we got to go right 6 spots. All right, let's graph it. Ooh, that's a long ways over there. So 1, 2, 3, 4, 5, 6. So we have an absolute value graph. So you can remember what your absolute value looks like. This, that. And we've got it labeled. There's my parent graph. And then this says I'm going to move right 6 before I draw my absolute value graph. And I've got it labeled. Okay. After you get your parent graph, after you get the function that they want you to, you label them both, and then you just say, hey, is this up, down? Is it left, right? Which way are we going? Ooh, this one's horizontal. So we have a horizontal translation. How many units? 6. 6 units to the right. And that's what you need to do for each one of your questions. Okay. Let's do the other direction on absolute value. What number is this? I think this will be 6. Absolute value of x plus 3. Okay. There's nothing inside with your x. There's no number in there. So you're not moving left or right. This is out on the end, so this one decides up, down. So this number is up, down. And remember the up, down, it's not inside anything, so it holds true to what you think. So when you see positive 3, you're thinking, oh, positive 3 must be up 3. It is. So this is up 3. So let's graph this guy. So here's there. All right, we're still working with absolute value. So we have our absolute value graph. This is your parent function for absolute value. Graphed it, labeled it, and then you got your new function. Absolute value x plus 3. So we've graphed both functions. We've labeled both functions. Now we got to describe it. It's not horizontal, this is up, down, so it's vertical. So we got ourselves a vertical translation, and we're going up. 3 units up. All right, now we got this stuff. It's clicking now. Okay, so we've done quadratics, we've done some absolute values, done some linear. Oh, we haven't done any reflections. Let's do some reflections. All right, number 7. So that negative sign right in front of your x, that's the big key that this is going to be a reflection. And it's going to be across the x-axis. All right, let's graph it. This one's back to linear. So we've got a linear one. We know what the parent function looks like. So our parent function looks like this. But when you reflect it across the x-axis, this flops down, this flips over. You get your new function to graph. We'll do it in green, and it's this line. So you have y equals negative x. So parent function, new function, got them labeled. We got to describe this one, and it's not a translation, this is a reflection. And we went across the x-axis. Kind of a nice looking graph. Man, go Mr. Porter. All right, guys. I guess we could do one more. We could do it if it's a quadratic. Let's do one last one. And again, when you see that negative sign out in front, that's your ticket. You're like, oh, it's a reflection. I see that negative sign out in front. Let's graph this one. So I've got my quadratic, so I know it's a parabola. So there's my normal one. There's my parabola. This is your y equals x squared. There's my parent function. So you see the squared, you see the squared, quadratic. Now we've got to draw the reflection across the x-axis. So let's mirror image this down. And so you have one parabola running up, one parabola running down. Let's label it. So we've got a reflection. Oh, we didn't describe it. Let's do this. So this is a reflection. And this is across the x-axis. So for each question, you have to do 4 things. So you got to draw the graph, label it, get the parent graph, label it, run your description. What kind of transformation do you got? 4 things for each problem.